We are from G1-04 and our project title is POME Treatment from Plant Oil Industry. Malaysia's most significant export is oil plant, and oil plant mills have actually contributed to pollution problems. One of the physical water treatment processes is reverse osmosis, which has been commonly employed for the treatment due to its cheap and affordable cost. The reverse osmosis is a pressure-driven membrane process using desalination technique that utilizes a membrane which is permeable to water but impermeable to salt. For the problem statement, direct discharge of POME into land causes oil blockage, waterlogging, and immediate plant death. And there is always been a doubt about the efficiency for the approach, and the suitable control system need to be identified to ensure the effectiveness and quality of the process. Objectives of the project are to increase the effectiveness of RO process for the treatment of POME, to investigate and identify an effective control system for RO, and to learn about the difficulties of employing process control system in the chemical sector.
For this project, we have discussed the effective waste control system for zero waste for the wastewater treatment industry from POM. As you can see, the figure on top is the schematic diagram of POM treatment process plant, which includes the pre-treatment, biogas utilization, sludge disposal, biological treatment until the reclamation of the clear water. The figure below shows the simplified process flow diagram of POM treatment, in which firstly, POM undergo pre-treatment, where gross pollutants from waste stream is eliminated. Next, during biological treatment, majority of organic matter is biodegraded. Then it enters microfiltration membrane to filter unwanted materials, and finally during reclamation, the discharge was pressurized into ultrafiltration units, and the permeate from the unit was pressurized into the reverse osmosis unit to produce the final discharge. For the control system, we discussed on the reverse osmosis process. To increase the effectiveness of reverse osmosis, pressurized recycle control system is used for POM treatment. Firstly, raw wastewater undergo pre-filtration to remove any large particle and pass through an oil-absorbent vessel for oil removal. The de-oil water is sent to the reverse osmosis membrane through a high-pressure tank where it mixes with recycled concentrate from the membrane. It separates the flow into concentrate and permeate streams. The permeate is removed while the concentrate is recycled. For this type of control system, there are two variables that are controlled, which are the feed flow rate and the feed pressure, while the manipulated variables are valve position on recycled stream and high pressure pump motor speed respectively.
I will continue the presentation by elaborating the challenges on existing control system. There are 3 points have been discussed. First of all is energy consumption. Referring to what 2019, the process of screening wastewater consumed between 3% and 50% of nation electrical power, which is quite big. Majority of RO system require continuous operation and it depends on pumping of the wastewater throughout the system. Based on the pie chart, pumping holds almost 1/4 of overall energy consumption, and this also indicates more cost operation. Moving on to the second point, which is wastewater sludge disposal. The production of sludge is very common as it can be used to recover resources and energy, but the excess of it may burden the system. When there is high flow rate of sludge, the disposal becomes slowed down due to the shorter HRT. This will lead to the higher OLR and F/M ratio, which later generate bigger size of sludge and causes falling. The graph displays how short the HRT rise operational TMP, that proving the sign of faster membrane falling. The last challenge is pressure drop or pressure of the system. Around 4 to 5 psi per element is considered as normal pressure drop value for a commercial RO membrane during its usual operation. Delta P will not change if temperature and flow rate is kept constant. Higher pressure help to increase salt rejection, but if too high of pressure detected by the fluctuation of the controller, it can slow down the performance and can damage RO membrane. As pressure and temperature affect each other, the controller should operate really well.
Based on the challenges discussed earlier, the integration of artificial neural networks or ANN for controller auto-tuning has been recommended to optimize the efficiency of the existing control system used for the reverse osmosis treatment. As integration of ANN is an adaptive control system, the model developed can be used to learn the behavior of the treatment process. It can then produce the necessary response to any deviation in the process variables. Since regular retuning of controllers are required to check on the performance of the controllers used, having fully trained ANN model would be very beneficial to estimate the new tuning parameters more accurately, as the model developed are rarely oversimplified, unlike the conventional auto-tuning methods, which means that the controller's action would be more robust. Apart from that, real-time optimization or RTO systems can also be implemented within the control system for resource efficiency. The main goal of implementing RTO into the control system is to maintain the process operation to its optimum point by taking into account the profitability of the whole operation in terms of the operating conditions as well as environmental regulations that need to be adhered to by the operation. By changing the operating conditions of the treatment plant, lesser energy is required by the subsequent control system to provide corrective actions should there be any deviations observed in the process variables. If the same operating conditions are used despite the frequent fluctuation in the process variables, it is obvious that more energy will be needed to correct a drastic change in the process variables of the process.
Our group successfully discussed palm treatment from palm oil industry, which is a waste management solution for the Malaysian oil palm industry. The discussion covers the environmental chemical engineering factors and the process control. To achieve the zero waste goal, our palm treatment process is required with a few treatment stages such as palm treatment to remove gross pollutants and safeguard downstream equipment, biological treatment to decompose organic matter, and reclamation stage, which includes ultrafiltration unit and reverse osmosis unit that utilizes reverse osmosis membrane separation process. There are several challenges with the reverse osmosis control system that are addressed in order for us to discover the real industry, which are high energy consumption, wastewater sludge disposal, and the pressure drop, pressure and fluctuation of reverse osmosis system. There are a number of techniques to solving the challenge that have been raised, such as integration of artificial neural network for controller auto training and implementing real-time optimization for resource efficiency.